Blender is a fairly sophisticated modelling and animation environment which I began to learn just about from scratch, although I had some previous knowledge of similar packages and the terminology involved and what's involved in getting together an animation. However, Blender's interface has many configurations, and that took some getting used to. For instance, you can put portions of your model in different layers to keep them out of the way, eventually bringing them back for the final render. But of course, if you forget to bring them back, then they don't appear in the final render 4 hours later. Testing the feasibility of whether I could actually get an eye model together, I obtained very simple results at first. One of the hardest aspects we found was me understanding the briefing accurately. All the different orientations and terminology concerned with ocular scanning. I was given a sheet of scan positions for the right eye, and worked also from Dr. Atta's book on ocular scanning. But often I misunderstood exactly what was required, and many hours were spent waiting fruitlessly for long renders to complete, and then finding out they were wrong. And sometimes I did understand what was required, but I couldn't actually get Blender to do exactly what I wanted. Consequently, we developed a variety of means for communicating required changes from one render to the next. Email illustrations, sitting at a desk, annotating screenshots, even whiteboarding with Skype. And to cut down on the rendering times, I began experimenting with batch rendering and leaving the computer on all night. In Blender, another difficult thing was achieving consistent texture mappings. That's the process of flattening out a model, making a painting of the details that should go on its surface, and then applying that picture back. It's called a texture map then, and correctly aligning it back to the model where it should go. It turned out to be more of an art than a science, and something that there's always room for improvement with. It's a question of time. As I became more familiar with Blender, I realized that it had very sophisticated outputting methods. It could do a variety of different formats. It involves linking together nodes into a pipeline, and if you get some open source Python scripting off the net, it can output stereo images involving twinned cameras. The results can be either anaglyphic, which is useful during development when you're not near any sort of stereo projection equipment, or side-by-side stereo, which Present 3D uses, which I'll just speak about in a second. It happened to be a parallel project I was engaged in at the time. Just recently I discovered that it was possible to prepare these models for export to the Present 3D environment, and that was quite a breakthrough. Present 3D is a parallel project I was working on involving the automatic collation of DICOM scans into their 3D form, almost like laminating all the slices back together again to make something 3D, and then floating that in virtual space. It's called a volume by this time, and it can be displayed interactively in 3D stereo with the aforementioned special projection facilities, which is basically two projectors with polarizing lenses over them. It's similar to what you see in the currently popular movie Avatar. However, volumes are quite computationally heavy, and so they're difficult to move easily without a very powerful computer, especially when you're trying to make a screen movie at the same time as I am here. So this really serves only as a rough impression, and hopefully it'll be followed by a live demo of Present 3D, which will give you a better idea of the resolution that is achieved by it. Present 3D is also still a work in progress. It involves writing presentations in XML. Recently, the facility to colour the results of the volume based on Hounsfield units, density units, referencing colour lookup tables was added, and my early experiments show that I've got quite a lot of way to go understanding which colours to apply to which densities. So we're getting psychedelia here. But the possibilities are there, and it's actually already working. And especially the ability to export 3D models into Present 3D environment opens up possibilities for merging MRI volumes with models. So you could take an MRI volume and then show it, allow students orientation, and then fade it into a 3D model which clarifies the situation like a diagram clarifies what you're actually looking at in a photograph. So it can take the thing and make it clearer, and it remains interactive. We can move the model, we can move the wand up and down in space and so forth. Both these projects that I've been working on in tandem have required that I do quite a lot of reading in the aspects of visual computing. And reading them and getting to know what they're saying has opened up further possibilities for exploitation in that field.